All right. Hi, folks. I hope you've had a nice day at the fair. We're going to get started just a little early since the last presentation ended a little early. So this is getting started with 3D printing, and it's sort of just an introduction to 3D printing and what it's all about. I hope maybe at this point you had a chance to stroll through the 3D printer village and get a look at what all that is about. We'll talk for about 15 or 20 minutes, and then I'll answer any questions you have, and we'll go from there. So first of all, what is 3D printing? You might hear this word, additive manufacturing, which is shorthand, or it's, I guess, the technical term for the shorthand term 3D printing. And it's really any manufacturing process that builds up a design layer by layer. And these days there are a lot of different machines that do that in different ways. A lot of the stuff that you saw in the 3D printer village is called fused filament fabrication. And you might, I think Shapeways has some more higher end machines. There's a lot of different technologies that you can access through other technologies. But essentially all of these designs create layers that are either extruded through a nozzle, like a precise computer controlled glue gun, or cured by a laser or a projector beam. And we have a little video there sort of showing a fused filament printer building up a design layer by layer. And on the side there is a photograph of a stereolithography machine, which is like the Formlabs machines. So what can we use it for? People use 3D printing for all sorts of things. Design, create works of art. We've got some really awesome examples here of Mike Gansky's work. Is that big sort of object in the center, and it's hard to tell from that picture, but that piece of work is like pretty ginormous. Gaming miniatures, some heart gears, just anything that inspires you. Or you can make a prototype, touch your ideas in real 3D dimensions. People use 3D printers as a first design step in professional product design, but you can also use it at home to prototype any project that you want to make. And invent and share your dreams. There's a lot of people who are not only creating things from themselves, but also sharing them online on lots of file repositories like Thingiverse and GrabCAD, so that not only are you creating these ideas for yourself, but you're giving them to others who can reproduce them with their machines as well. So what can we use it for? There's some really cool technologies out there to capture the world around you without needing to know modeling or know much 3D modeling at all. There's 123D Catch and scanning with Connect scanners, and all of these are examples of scans that people have made and then printed them out either after they've done some post-processing, but it's a great way to interact with the world around you and keep it and take it home. Some other cool projects. These are all examples of projects that make a difference. The cool thing about this type of design work is that you can really solve an individual problem. And then sometimes when you solve your individual problem, you realize that there maybe are 50 other people like you. The little boy in that picture is holding up a robo-hand. And if you haven't seen that YouTube video, it's really worth checking out. It's really cool. It was a carpenter, I believe in South Africa, who had an accident and was missing his fingers. And he was looking for a prosthetic that would allow him the dexterity that he needed for his job. And he, along with the help of another 3D artist, created something that worked for him. And then he realized that there are all these kids, I believe it's called ABS. It's essentially where they've had bands wrapped around their limbs in the womb, and so they're missing fingers. And so they were able to sort of use the same ideas and translate them from these kids. The problem with kids is that they grow so fast that it's not worth getting a prosthetic made until they're much older, and so they miss out on a lot of cool things. And so desktop 3D printing and 3D printing in general are great ways to solve problems that a big manufacturer might not take the time to solve. So what are the 3D printers that we can sort of access today? There are two kinds of desktop consumer grade printers that you're going to see, and you can see both of them in the 3D printer village. Fused filament fabrication is the first one, and that's the one that anybody who's really had exposure to this industry, like that's the one you've probably seen the most of because it's been around the longest, and by the longest I mean about 4 or 5 years tops. And these ones are the ones that work a lot like a highly precise computer controlled glue gun. They have a nozzle and a thread of filament that's fed through the nozzle that is controlled by a computer generated path. And then we have stereolithography, which starts with a vat of resin, and a laser cures it layer by layer, and you essentially get a form that sort of emerges out of the resin. And this is typified by two kinds of printers. First, the B9 and the Form 1. Which are also both here and really great to look at. The SLA tends to be higher resolution, but also a lot slower. And the fused filament fabrication, while also not the speediest technology around, is a little faster than the stereolithography. And those of us who are in the 3D printing community are sort of excited because there's some key patents that are expiring in the coming years. The patent for selective laser sintering is expiring pretty soon, and so it's not going to be very long until we see that technology accessible in consumer-grade printers. But you don't need a desktop 3D printer to use or to make a 3D print. You can use a service bureau like Shapeways or Sculptio or iMaterialize. And all of these services allow you to create a design on your computer and then upload it, and they will manufacture it and send it to you. Obviously, it's a little bit longer of a process than having one on your desktop, but it really opens up the range of the types of materials you can print in. All three of these companies do ceramics and metals in addition to the common plastic materials. So what should you print? A lot of people find a model. I talked about both Thingiverse or GrabCAD before. But especially if you have a printer at home, after a while, that's not very exciting. Usually you want to start printing your own objects and your own designs. And there's a lot of new modeling programs that have cropped up in the last few years to try to address these markets. FreeCAD is one, Autodesk 123D is another, Tinkercad is another program that's really easy to get started with. There are lots of lists online of a broad range of programs to suit different people. People think it's really hard, and it is at a certain point, but it's pretty easy to get started with simple projects. This is a screenshot from, I think it's from 123D, although 123D and Tinkercad are looking pretty similar these days. You can create 2D line work, either in a program like Inkscape or Illustrator, and then extrude those lines out into 3D. And then once you've got some basic shapes, or you can start from primitives like cubes or spheres or pyramids. And once you have these basic primitive shapes, you can manipulate them in different ways, combining them, subtracting one from another to create a 3D part. It takes some practice, but it's not really that hard. There are lots of tools that I mentioned before that you can give a try. And then you can take your projects further. Todd was up here about an hour ago talking about some of the cool things he does with casting. The big horse head that you see on there is actually like a full-size replica that was taken, a scan that was taken of a sculpture. So that thing is like really big, and then finished with sort of like a metallic patina. There's also a image there of somebody who did a food-safe silicon mold from a 3D print, and then made some tardies, suckers. And there's some people who are experimenting with the finished model as a lost wax, or a lost PLA is often called, casted part, or taking the model and making a subtractive mold from it. And you can print a lot more than plastic. Like I said, with the service bureaus, you can create 3D prints and materials like stainless steel and ceramics. But remember that additive manufacturing is actually any manufacturing process that is computer controlled and builds up layers, designs in a layer. Let me say that one more time. Additive manufacturing, because it's important, it's any process that is computer controlled and builds up a design layer by layer. And so when you hear about people are printing tissue, or they're 3D printing a house, or they're 3D printing cells or sugar or food, essentially what that means is they're just using a process, they're using a machine to really accurately place and then cure layers of some substance in place. And that technology is already here. So when you hear it in the news, now you know what it is. Lots of resources if you want to take this a little bit further. Make's Ultimate Guide to 3D Printing is coming out in mid-November, and it's a great printer issue. If you're looking to buy a 3D printer, it's a bunch of reports, lots of tests, and reviews of some of the best printers on the market, as well as just some resources for getting started on the right foot. And this is me. My name is Kacie Hultgren, and that's how to get a hold of me. I go by the name PrettySmallThings online. And I would love to ask answer any questions you have to ask. How do you quantify the resolution of a 3D printer? So in all 3D printing, there's a term called Z height, and it's essentially like the layer height, and that's given in either microns or millimeters. And a lot of people these days say it's like, oh, a high resolution print is 100 microns or below, and that's referring to the thinness of a layer. And 100 microns is equal to 0.1 millimeters, so don't let the metric conversion stop you from understanding like the real underlayer there. The trouble with all of these technologies is that when they're talking about resolution, they're only talking about one axis, and three-dimensional shapes have an X and a Y and a Z. And usually the X and the Y resolution is not equal to the Z resolution, but nobody talks about that. But that's the best comparison between technologies. For the most part, the fused filament machines that are out there, most of them can meet 100 microns. That's pretty standard these days, and that's a high resolution print, and it's going to meet most people's needs. When you go to something like the Form 1, the B9, the SLA technologies, they can reach much lower lower layer heights, which is higher resolution. Yeah.
In terms of design software, is there any advantage of the Mac platform versus Windows platform?
He asked, is there any advantage to Mac versus PC when you're choosing CAD software, or vice versa? A lot of the programs these days are cross-platform. I don't think that there's a big difference between any of them. Even some of the big holdouts like Autodesk recently released like AutoCAD for the Mac, and they're taking a lot of their software to both platforms. I think it's pretty common these days that you're going to have lots of options regardless of the platform. And in fact, it's the web-based cloud services that are becoming more popular, both the 123D Design Online and the Tinkercad, which are really good for getting started, are web-based, as well as Autodesk has a, what is it called? Sort of an inventor-like program that's really good for assemblies and has some really great feature sets, and that's also an online platform. So I think that's sort of where things are heading, and platform's not going to matter that much in a few years anyhow. Anybody else? Yeah.
When you're trying to prototype parts with these printers, is there any shrinkage that needs to be considered? The other tolerance aspects?
Yeah. There definitely are some tolerance and shrinkage differences with the desktop machines. And so there's some key differences between when we're talking about the fused filament machines versus their sort of, its parent technology is not the right word, but FDM is the high-end equivalent, and those machines really start at like $5,000 and go really quickly up into $30,000, $50,000. And when you're talking about those high-end machines, they can definitely replicate dimensions very accurately, and they can do it for a few reasons, because the material they're using is proprietary, it's really well controlled, and it's machined to a high tolerance, and it's often kept in a environmentally captive situation, and it has a DRM chip on it. And so that filament, because they know exactly how big it is, in addition to the fact that those machines often have chambers and more complex technology, everything is going to be exactly what you think it was. Everything is going to be exactly what you designed it to be. When we talk about the machines that you walk by, for the most part out here, the ones that are sort of in the 300 to 3,000 mark, especially on the smaller end of things, there are going to be some tolerance differences. And I think it's important to recognize that almost none of those companies will publish like a percentage accuracy point, whereas the high-end machines will. And a lot of that has to do with the material that they're using. You can buy from anybody, and that's why it's cheaper. ABS, which is one of the plastics that you can print in, does have about a 2 to 4% shrinkage. But I actually don't think that is most often, I don't even think that's the cause of it. It's more that you have variations in the filament diameter, and that you have variations in how the machine is set up. Tend to be what's holding you back.
What will be the best material?
Well, PLA is a little bit more dimensionally stable. It doesn't have the shrinkage that ABS has. The trade-off is PLA tends to be not as stable at high heats. So if it's something that's going to be, for example, if you left it on the dashboard of a car in the summer, it's going to melt, whereas ABS is going to be much more stable. There are tons of people who prototype ideas on these machines, but if you need a hole that's 1 millimeter wide, you need to design it to be 1.2 millimeters wide in the software. And so it depends sort of what your goals are. If you're prototyping an idea that you're going to then produce in another process, you have to be cognizant that it's going to reproduce a little bit differently. And if you're prototyping an idea that is going to be, just produced for you at home, then you just want to accommodate the thresholds of the machine. I'm not an expert on that particular topic. I believe it's a laser sintering process, and so it's like steel powder in with the nylon powder, and so it's laid down in a powder form, and then it's cooked essentially so that it all fuses together. Yeah. Between the different pricing tiers. He's talking about, it's like a lot of people want to know what printer should I buy, or does it really matter? Should I drop $3,000, or is that $300 machine going to work better? And it really comes down to, I think, there's a lot. That's a big question, and I think you know it. Some of these companies have really big groups of users behind them because they've been around for a while. And then some of these companies are fresh off Kickstarter and they're charging less, but there's not going to be a group of community to go to if you have a trouble. Some of these machines are priced as kits, and some of them come assembled. And some of them are just easier to calibrate, and others aren't. It's hard to answer. Like in Make Magazine's, in their guide last year, they sort of gave like best in class to like 3 different machines. Sort of in the high end, you have the MakerBot replicators and the Ultimakers. There's a lot more in the mid-range these days. In terms of the kit and the rep wrap and sort of associated models, but there's also this sort of like separate area that includes the Up and the Cube, which are a little bit more polished in terms of being a finished consumer product, but they don't have the speeds and they don't push the resolution. They don't push the resolution, and they don't push the speed. And that's great if you want it to be more reliable, and not so great if you're willing to put in a little time to make it work better or work faster. And then you have machines, like the PrinterBot Simple, which is like $300 unassembled, and like even the Bakito, which is sort of under the 1,000 mark. Yeah, one of the big things that drives, that's not a terribly concise answer for you, but there's a few things I think that drive price. There are 2 materials that you print in with the desktop machines, and they either print in PLA or they print in ABS, and there are pros and cons to both. If you're going to print in ABS, you have to have a heated build plate. And if you print in PLA, you can either have a unheated one or a heated one. And that element can really drive up the cost, especially if it's a printer that prints large. And so that heated bed, whether you have one or you don't, is one thing that drives up cost. And another thing that drives up cost is just overall size of the printer. You can get a fast, really nice printer, but it only makes something that's 100 by 100 millimeters. If you blow that printer up so it can print 300 by 300, the price is going to be at least double, if not triple, just because of the extra components and the, especially the more expensive heated build platform. So it's like, its size. I don't even think quality is that big of a deal. It's more about how well tuned the machine is when it comes to you, and that really comes down to ease of use. I think you've got printers on the low end which print sort of small and maybe need a little more help to get going. There's a ton in the mid-range, and then there's more on the high end that either have like pro features like an SD card interface so you don't have to be hooked up to a computer, ones that will let you cold pause so that you can turn it off before you go to bed at night and then turn it back on in the morning and restart your print. So if you're looking sort of for that more pro feature set, the higher end printers will do it for you. You can come find me after if you have specific things you want to talk about. Anybody else?
You said the services, how do they charge?
Say that again?
The services. You want to print something for a service?
Yes.
How do they charge?
They're always charging by volume. There's a couple processes that charge by surface area, but for the most part it's volume. And that's one of the reasons you'll see a lot of really cool sort of like cellular structures and lots of wire forms when you look at websites like Shapeways, because that sort of stuff is cheap to print. It's actually really expensive to print like a big solid ball. That is going to be really easy for a desktop machine to print. Whereas those cellular structures that have lots of like thin lines that like don't seem to follow gravity is going to be really hard on a desktop machine. And there are various processes that sort of have different price points. The metals tend to be pretty expensive. The most reasonably priced processes are the laser sintered nylon, which is a really versatile material because it both has strength and flexibility, and it's sort of a basic white color. Anybody else? I appreciate you stopping by here at the end of the fair and listening. And if anybody wants to stick around and has some other questions, I'd be happy to answer them. Thanks, folks.